difference of squares. Whenever you see something squared, that means something times itself, right?
Yeah.
All right, what does difference mean? Subtracting. So you are going to see things today that are they're going to be working with numbers that are squares of other numbers. So you guys just tell me, what's 5 squared?
25.
What's 7 squared?
49.
10 squared?
100.
15 squared?
125.
Not 125.
325.
Nope.
525.
Nope, lower.
425.
225. All right, so we will be seeing numbers that look like this. So let's make a list of the numbers that you are going to see show up a lot today. So here are the numbers of perfect squares. Perfect squares are just a number times itself. So let's just make a list. Everyone tell me, what's 1 squared?
1.
All right, what's 2 squared?
4.
3 squared?
9.
4 squared?
12.
Nope, try again.
16.
16. All right, you guys told me 5 squared's 25.
36. 42. 81. 100.
All right, so let's stop there. That's 1 through 10, right?
Yes, ma'am.
All right, now on the next, I'm going to make another line going 11 through 20. So 11 squared, you guys know that? 12 squared? 13 squared? 14 squared? Yep. 15 squared, we just established that's 225. 16 squared?
336.
Not a little less than that, but it does end in a 6. That's a good guess.
256. 256.
256.
Oh, quit cheating.
17 squared is 89. 18 squared?
312.
Up a little bit more.
324.
324. 19 squared is 361. And what's 20 squared?
400.
All right, so I like making this list. So that way whenever you factor, like if you see I don't know, let's just say that you see 17 in your list and you're like, oh, I know 289 is a perfect square, but I don't know what it is. You can find 289 and then say, well, that's 20, 19, 18, 17. You can kind of use this as a little cheat sheet.
Oh, we can use it on the test. Put her on the spot. Hey, for the discount.
Well, being the fact that I give you a calculator, probably not.
Oh. For the discount. I'm going to give her the discount.
All right.
No, I wasn't there to give her the discount.
All right.
She has been there.
Hey, guys, the virtual kids don't care about that. All right, let's go. All right, so the reason why we do this is there are some special cases, and I'm going to show you guys where this comes from. So let's just go back to last week when we were doing the distributive property, and you see something like this. 5x minus 1 and 5x plus 1. If you would actually distribute that, what is 5x times 5x? 25x squared. And then 5x times a positive 1. Negative 1 times 5x. And negative 1 times a positive 1. Hey guys, what happens to those? All right, and it ends up being 25x squared minus 1. So look at this answer.
Pardon the interruption. Would all class officers please report to the comments?
All right, so if you take a look at this answer, 25x squared minus 1, do 25 and 1 both have square roots? Are those numbers both in your perfect square list?
Yeah.
Yeah. What's the square root of 25? What's the square root of 1?
1.
Hey, go back and look at those parentheses. What did we start with? 5 and 1. So whenever you have a difference of squares, You can simply just take the square roots. You don't actually have to do any of the work. So this is just the general formula for difference of squares. And I'm just going to use A and B. So if you have two things that are perfect squares and it's subtraction, we can simply say that the factors, one is a plus and one is a minus, because what happens whenever you do these difference of squares, the distributive property, those middle terms end up becoming 0 because they're opposites. So AX plus B, AX minus B. All right, so let's go through a couple of these examples. The first one I want to do is 36x squared minus 49. All right, are both of those numbers on our list? All right, so they are on the list. They are perfect squares. So you guys can automatically, if you see that it's perfect squares and it's subtraction, we can go straight to the parentheses. No work is involved. What's the square root of 36? All right, and then how do you get x squared? That's x times x, right? So we can do 6x, 6x, because that gives me 36x squared. Now what's the square root of 49? All right, and then to make it a negative 49, doesn't it have to be one positive, one negative? Then that's it.
Doesn't matter which one.
Nope, order doesn't matter. You can put the negative first and the positive second. You guys like these?
I remember these.
Yeah, you did these in Algebra 1.
Yeah, I knew it was something like that.
All right, what about 16x squared minus 25? Are those on your perfect square list?
Yeah.
All right, so they're both on the list, so let's talk about it. What's the square root of 16? So how do we get 16x squared?
4x.
4x and 4x. How do we get negative 25?
Plus 5 minus 5.
Plus 5 minus 5. Now, what about this one? X squared minus 81. Is it okay that that first term doesn't have a coefficient? It's a 1, right? And that's a perfect square. We just never write the 1. So how do we get x squared? X and x. How do we get negative 81? And one's a negative, one's a positive. So far, so good? All right, I've got one more for you.
How many questions are on?
Like 6. Oh, that's supposed to be a 54. Hang on. 6x squared minus 54. All right, are those on your perfect square list?
Nope.
Definitely not on your list.
No brainer.
All right, so let's use that. You know how yesterday we multiplied stuff to make it do what we wanted to do and then divided it at the end? Do you think it's okay to divide first and then multiply later? All right, what's a number you could divide both of these by?
6.
Oh, definitely go with the biggest one if you can.
6.
All right, if I divide these both by 6, we can do that. So this, we divide by 6, and we end up with what? What's 6 divided by 6? All right, so that'd just be x squared. What's 54 divided by 6?
9.
Hey, do we like that type of problem?
Yes.
All right, those are perfect squares. Sometimes when you divide, it makes it work out the way you want. So if I wanted to factor x squared minus 9, what would that become? X minus 3, x plus 3, because the square root of 9 is 3.
Yes, ma'am.
Now, what did we divide by to make that work?
6.
All right, so guess what we're going to do? We're going to just multiply that 6 back at the end. So we divide by 6 to make it do what we want to, and then we multiply by this, just multiply it back in. We don't even have to like distribute it, just throw it in the front. So do you guys want to do one more like that?
Yes. I think we got it. I'd like to do it for
I'm going to write it down.
Bro.
So let's go with
I need chili. I did not.
8x squared minus 50. What can you divide 8 and 50 by? You can't divide 50 by 4. All right, so guys, 8x squared minus 50, we would divide this by 2 because they're not perfect squares. But what happens when you divide those numbers? What's 8 divided by 2? So 4x squared, what's 50 divided by 2?
25.
All right, do we like those numbers?
Yes.
All right, what's this? How do we get 4x squared? 2x and 2x, how do we get negative 25? Plus 5 and minus 5. And then what do we need to do at the end? All right, we got to put that 2 back in front of it. And there we go. So guys, we will be doing more practice with factoring. You guys do have, I believe, is it 6? Correct me if I'm wrong. 6 of these to try on your own. Oh, it's 8. Sorry. All right, so I will let you guys work. I know, I apologize for not giving you guys as much time to work today, but I wanted to make sure that you guys did get to see more examples from yesterday since I was not in here.
It is okay.
All right, so if you guys have questions on anything, let me know. And then I will get this